have one page of notes today. They are super duper short. It's just this front page and that's it. So here we go. Alright, so we are going to solve equations and inequalities, but again, today, just the equation piece. Tomorrow we'll do the inequalities. Solving reminders. We want to make sure that we perform the opposite operation to eliminate values. Meaning, if you are trying to solve and you want to move something to the other side, if it's added, you would subtract it from both sides. Also remember that whenever you have equations or inequalities, it's like a balance. So anything you do to one side has to be done to the other so it doesn't throw off said balance. Alright, so let's look at some equations. Kind of similar to the warm-up, even a little bit trickier, I think, than the ones that were on the warm-up. Alright, number 1, part A. I think the first thing you've got to think about here is like, what am I going to do first, right? Like, what's my plan of attack? If this was your problem, what would you think of to do first? Distribute. Let's get rid of those parentheses. So I'm going to take that 8 and I'm going to multiply it in. So I have 7x plus 8x minus 24 equals 12 minus 3x. Now, we've got some chaos because we've got variables on both sides, we've got numbers on both sides. Before I deal with any of that, I'm going to deal with the fact that I have two variables together on this side. Those are like terms, yes? So let's combine them. 7x plus 8 more x's, how many x's do I have? 15 x's. So 15x minus 24 equals 12 minus 3x. Okay, so I tidied things up a little bit here. Now, let's get our x's together. We have a choice, and it doesn't matter which one we pick, because we're still going to get the same answer. I think what I'm going to do is move this 3x over. How can I move it off of the right-hand side? How can I make it go away? Add it, right? You do the opposite, because what is negative 3x plus 3x? 0, so it's gone, right? So this is gone if I add it. But again, think of your equation like a balance. I can't just add 3x to one side, right? That throws me off. I have to add it also to the other side. And I'm going to add it right there with the 15x because those are like terms. So I get 18x minus 24 equals 12. What would you do next? Yeah, let's get the plain old numbers together. So add the 24 over, and I get 18x equals 36. And then when I divide by 18, what do I end up with? 2. Now, one of the nice things that I like about solving equations, because I like leaving a test or quiz knowing like I did pretty well. Like I always get nervous. I always think, oh, I did worse than I think I did. With tests and quizzes where you solve equations, you can check, right? You can plug it back in and see, like, did I do it correctly? So you can plug it back into the original equation and check and make sure the left and the right side are equal to each other. So that's an awesome thing about solving equations, is that you can have that double check. So that's something I like about those. All right, I'm going to kind of section this off because I wrote a little bit over into the other spots. All right, let's see. The first thing I did in A was distribute. I don't see any distributing in part B. Where might we want to start in part B? What is it? Like terms. I see some like terms too. You see some like terms here? Alright, so I've got 14.3 minus 6.5, and that gives me 7.8. Yes, you can use a calculator. Again, I will tell you when we encounter a section where there might be a portion of the test where you can't use it on. I will let you know way ahead of time so we can make our mental peace with that. This is not one of those units. do what? Say. Oh, I lost my 0.3. Thank you. I wanted it to not be a decimal apparently. 10.3h plus 9. Sorry about that, guys. Alright, let's move our h's together. So what do I need to subtract from each side? I think I'm going to go this way. Yeah, let's subtract the 10.3. I know it's going to make it negative. It's not my favorite, but yep, I'm going to subtract it from this side. So I have 7.8 minus 10.3. So I end up with negative 2.5h equals 9. Now what do I do? Divide. If I divide by negative 2.5, what do I get? Is it? Yep, I agree with negative 3.6. And again, we can double check our work, plug it back in, make sure it works. Do you remember the trick that's different with inequalities? Remember, tomorrow we're doing inequalities. If I multiply or divide by a negative number with inequalities, what happens? Do you remember what happens to the inequality itself? It flips. So we're going to have to deal with that extra bit of information tomorrow. So again, another reason to kind of keep them separate. Let's see. Did I leave you a packet back there? No? Oh. Alright, next one. Do you see how we have fractions? Okay, and it sounded like from the warm-up, the fraction one was the trickiest, yeah? Because a lot of people who said, oh, I only missed one, it was this one. Okay, so the first thing I would do is look for a common denominator. Not because I want to add everything together, but because I actually want to multiply by it to get rid of the fraction. So what would be a common denominator for part 2? I can't turn 4 into a 2, like I'd have to multiply it. Yeah. So 8 would be a good common denominator, right? So when I go through, I'm going to go through and I'm going to multiply each term by 8. So you want to find your common denominator, because what you're going to see in a second is that's going to help your fractions magically disappear. Now, just like we talked about before, if you do something to one side, it's legal as long as you do it to the other. So I went through and I multiplied absolutely everything by 8. I didn't leave anybody out. Everything got multiplied by 8. Okay, remember when you have fractions, this is like 8 over 1. 8 times 3 is what? 24. So I get 24 over 4 times 1 is 4. Minus 8 times 1 is 8. 1 times 2 is 2. And then again, we can think of that as a fraction. Remember, we multiply numerators, so 8 times 5 is 40. 8 times 1 is 8. Do you see how all of those are going to simplify to non-fraction things now? What's 24 divided by 4? 8 divided by 2. 40 divided by 8. 5. Now, this is a step that I typically skip. This is not a step I typically do. Normally I go straight from here to here. If the in-between step helps you, you can always do that. If you don't need it, you can go straight from here to here. So the way that I process it is I think, how many times does 4 go into 8? Twice. 2 times 3 is 6. So that's how my brain would walk through that if I wanted to do it in one step. Alright, now I live here. Isn't this much nicer? Okay. How can I move my numbers together? Yes. Subtract 6. Negative 4n equals negative 1. And then what? Yeah, divide by negative 4. So n equals a negative divided by a negative is a positive. And for these problems, I don't mind if you leave them as a fraction, if you leave them as a decimal, even if it was something, like if it turned out to be improper and you want to leave it as a mixed number, that'd also be fine with me. Okay. How'd we do on those? Did it coming back a little bit? If it didn't in the warm-up, is it coming back now? Okay. Now, the other thing we can ask you to do, and again, this is still on today's stuff, is I can give you an equation. So for example, this one is finding the area of a trapezoid. Does that look familiar from last year? So this was base 1 plus base 2 times the height times the half. That's how we find the area of a trapezoid. So let's say that's our formula, because I mean, it is a formula. And let's say I want to solve it for B1. So we've got base 1, so B with a little subscript next to it. I can solve the equation for this. I'm not going to get a nice answer like I did up here, right? Like I'm not going to get n equals 1/4. I'm not going to get anything like that. I'm going to get a whole formula when I go to solve it. Alright, so let's start with, actually I'll start up here. Do you see how there's a 1/2? Remember how I like to get rid of fractions? What can I multiply each side by to make the 1/2 go away? I see people telling me 2's. Or to be more peaceful. I don't know which. But I think 2's. Okay, so now I'm here. So I multiplied each side by 2. This 2 and this 1/2 counteracted each other, so gone. 2a on this side. So I have this left over. Okay. Now, do you see that pesky h out front? I want to make it go away. If h is being multiplied to that parenthesis, how can I make it go away? Yeah, but then there's just going to be more h's. I want to make it go, but away. Divide by h. So remember, we do the opposite operation. Yes, I know that brings back a fraction, but we're going to make our peace with that. So I have on the left 2a over h equals b1 plus b2. I can drop my parentheses because at this point, right, they're not really helping anybody. How can I get b sub 1 by itself? Subtract the b sub 2. Here's the good news. I'm not going to make you get a common denominator and do all that business. Once b sub 1 is alone, I'm a happy camper. Okay, so if I subtract the b sub 2 over, I'm going to have 2a over h minus b2. Base 2, base sub 2, whatever you want to call it. And this is my final answer. Now, could I put this over 1? Multiply it by h, could I get a common denominator and condense that down? I sure could. You don't need to do that. Unless that's something that you're like, no, but I really want to. Go ahead. Will not take that joy from you. But again, really what you're doing is you're trying to get the thing alone that they give you. So they said B1, so I got B1 alone. You hanging in there okay? Okay, one more. One more. Alright. You've got S equals 1/2. I'm going to change the L to a cursive L, so that way I know it's an L and not a 1. Alright, so the L is what I would like to get alone. What do we want to do first? There are actually 2 things I can think of that I'd be fine with. Yeah, let's move the B. I'm fine with that. That was one of my 2 things I was thinking about. So F minus B equals 1/2 PL. Went away from this side. So again, we're still trying to get L alone. How could I get rid of the fraction now? Yeah, multiply by 2. So everything gets multiplied by 2. Everybody gets a 2. So on the left, I have 2x minus 2b equals, these are going to counteract or undo each other. And let me write that 2 better, because I'm not really squaring, I'm multiplying by it. I didn't like where it was floating up there. So on the right, I just have my p and my l now. If p is being multiplied to l, how can I get rid of p? Divide. And so my final answer, L equals 2f minus 2b over p. Now, if if you're thinking to yourself, how on earth could this ever be helpful? If you had a formula that was originally solved for S, but everything that they were giving you could be plugged in and then you would have to find L. It just depends on what you're being given. So if I had a ton of problems to do where the teacher gave me S, B, and P and kept asking me to find L, find L, find L, this would be the way to have it set up because I could just plug them all in and find L, right? So that's the benefit of solving for different letters in formulas. That's it for today. So some of the problems on the homework are going to be solving like the warm-up and the first 3 we did, and then the others are going to be solving an equation to get a variable alone. We're going to start back over at assignment number 1, and you have a good amount of time. I will put my book under the dot cam. If you have your book, you can take it out. You can also take out a Chromebook and open the book that way. We've got lots of time, so everybody should start working. Page 79 is the homework. 1 to 9 are the solving, just the normal basic ones like we've been doing. And then the 12 to 14 are the formulas where you're trying to solve it for a letter.